Hello students. Till now we have discussed about what is the radio galaxy, and that means the types of radio sources, that is radio galaxy and star-like source, that is called quasars. Now before studying about quasars, we will have to study about redshift. What is meant by redshift? For that, that is specifically we are going to study redshift in astrophysics. Now you might have heard about before studying that we will have to know what is redshift about sound. Okay, so suppose that we have an observer here. Just imagine we have an observer. So this is the observer. Okay, so and suppose that we have a vehicle. Approaching the observer. Okay, so you might have noticed that suppose you are standing somewhere and some vehicle is approaching you, or some ambulance is approaching you, then what kind of sound do you feel? The sound becomes faster and faster when it is moving towards you, but at the same time when the vehicle has moved away from you. Okay, suppose this is a vehicle, now it is moving away from you. Fine. So at that time for you, when the vehicle is moving away, the sound becomes slowed down. So that is called Doppler effect. So if I want to show you, suppose this is a mean position of the equilibrium position of the observer. So suppose that this particular vehicle is blowing some horn or siren. So when it is coming towards you, suppose it is normal, and it is approaching you, it will become like this, isn't it? The sound becomes very faster. You just mind the siren of an ambulance. But when it is moving away, then it is like that, slowly. See, that is, the sound is not moving faster, it has become slowing. The frequency of the sound is reducing. So you can see that when the sound is approaching you, this is the position of the observer. When the sound is approaching, the frequency of the sound wave is increasing. Yes, so this happens when you are approaching the observer. The source of the sound is approaching the observer, and again when the source of the sound is moving away from the observer, you can see that frequency is decreasing. Okay, it means more number of waves in a particular area means more frequency. Here frequency is decreasing, so frequency is decreasing. Okay, again you know that if nu is nothing but c by lambda. So what happens if frequency is increasing, wavelength is what? Decreasing, and here wavelength is increasing. Understood? So that means the relative variation in the wavelength or frequency of the sound coming out of a source due to its relative motion with respect to the observer is nothing but this whole thing is known as Doppler's effect, okay, of sound. So what is Doppler effect of sound? That the relative change in the frequency or wavelength of a sound wave when the source is approaching and or moving away from the observer. Now interesting thing is that the same thing that is applicable to sound is applicable to light wave also. So for that I will show you another environment.